Hello, and welcome to Senior Code Review Buddy. My name is Chris, and today I'm going to continue to review some chess engine code written by ChatGPT. Today, we'll get ChatGPT to make an optimization to the code. So far, the code has just been running a standard MiniMax search to find the best move, which just looks at every node up to a given depth. We'll get ChatGPT to replace it with alpha-beta pruning, which will get us the same results, but faster. Thanks to the power of math, alpha-beta pruning is sometimes able to skip evaluating a node or group of nodes because it knows they can't impact the result. Now, since this code review is about changing an algorithm, it's probably helpful to go in a bit more detail about this algorithm first. Although alpha-beta pruning can be tricky to understand, so I'll just kind of explain it at the high level since it's not really going to impact our code review too much. Let's start by clarifying our current approach first, min-maxing. Basically, this works by examining every move up to a certain depth. Then at each depth, we pick the best move for the player whose turn it is. That's all. So what is alpha-beta pruning? Basically, it's the same approach, but we won't have to examine every node. When we examine the tree, we'll have two new values, alpha and beta. And we can use these to determine whether we need to examine a node at all, or if we can safely skip it, i.e. prune it. Alpha represents the maximum value the maximizing player has seen at that part of the tree, starting at -infinity, and beta represents the minimum value that the minimizing player has seen in this part of the tree, starting at +infinity. Whenever we reach a section of the tree where alpha is larger than beta, we can skip those nodes because the math says these upcoming nodes can't impact the output. This is a pretty high-level explanation and not very helpful if you need to implement this yourself. I've added a link to the Wikipedia page in the description below, which can be helpful in understanding this algorithm. And if you'd like me to do a video on alpha-beta pruning in the future, explaining it in more detail, just let me know in the comments below. So, like before, I gave ChatGPT a few prompts to add this functionality to a chess engine that I have in writing. Before recording my code reviews, I tried to avoid looking at the code it generated too much. I wanted my review when I recorded it to be as close as possible to a normal code review. I did poke around a little bit and run the scripts though, as I also want to try and minimize any clearly missing code. Still, this code review should be pretty close to me having my first real look at this code. So you'll get to see my thoughts and reactions in real time, just like if this was a regular non-ChatGPT code review. Now, before we go into this code review, let's see how this PR was created precisely and what the initial state actually was. I asked ChatGPT to replace the existing min-max function with an alpha-beta pruning function. And one thing I noticed is that when it was undoing moves in this new code, it left it to do to handle capture pieces. It was just always assuming that the square had always been empty, i.e. that captures never happened. So I then asked ChatGPT to handle this to-do now, and then I realized that undo move had been broken for our previous two PRs, which was probably causing a lot of issues in them. No visible changes for the state though. We've got the same files as before, doing the same things, no real changes in the tests, no new tests were added. All it did was it changed the name of the unit test that was testing min-max to a unit test that was calling alpha-beta pruning, and they both worked the same way by just calling the function and making sure it didn't crash. We still have the same 5 failures as before, which is probably a good thing because this was just sort of an internal implementation change, so our interface is basically the same, and we should be testing the interfaces. And no real changes in the test coverage either, which makes sense given we didn't really add any new tests. Alright, now that we've got alignment on what the starting state is, let's go to the complete and unedited code review. If you want to follow along, you can find a link to the PR in the description below. So here we are at the third PR. So yeah, this is just the shift from using the min-max algo to alpha-beta. So let's take a look at what we've got. Interesting. So yeah, this is something that should happen earlier. I'm going to add a note to Chris. But yeah, I missed out that when you're undoing a move, If you captured a piece, you need to put the captured piece back. This should have happened. There we go. I think I did comment though about adding some tests earlier on to make sure that captures worked correctly, but maybe not undo captures. So yeah, I might have missed something there, but yeah, that's a good thing to verify. All right. Interesting. Sorry, just realizing my first thought is we've got, actually, can I get the side by, oops. Yeah, here we go, split, line reload. Find this a little easier. Okay, because we've got is min-maxing, but I don't know if we, oh yeah, we still use that, okay. Alright, so we know how that used to work, so now, okay, if we've got, so we return the board evaluation and a none. Okay, so first thing is I'm trying to figure out what we return. Best move. Ah. Oh yeah, okay, because yeah, if we've made it to this point, we just want to return the board evaluation. There is no move, that's just sort of what had happened at depth 0. Okay. Alright, so we generate the legal moves, we change remove, that's kind of a nothing burger change. So yeah, max evaluation is negative infinity. We have our best move. There is no best move to start. So we start by looking at move in legal moves. So yeah, we see if there's a captured piece. Make the move. Then we... Okay, so basically what's happening here is we get our captured piece. We make the move. We go one layer deeper with this current board. And then we undo the move, which is what we need the captured piece for. So one thing that I'm seeing here and thinking about, board. Yeah, I guess because we're going into the board, that seems like we're going too deep into something we don't own. So this line doesn't seem right, especially because there might not have been a captured piece. It might just be what the square was. So, not sure about the name. Captured piece. Since it could be a square, maybe square previous contents. Although that's a mouthful of a name, but that's probably too long. But you get the idea. Okay. Yeah, I'm wondering, looking at this, does it make sense for, instead of going in this deep, should the board be keeping track of the moves that it's had? Because then we don't need to care. We just tell the board to... Yeah, because if we do that, we can then say, okay, board, make this move, and then undo previous move. Okay, yeah, seeing this here and thinking about this a bit, I think it maybe makes sense for a board to keep track, because one of the things we've not touched on too much is if there's sort of certain stalemate conditions, the board would know about that, so it would kind of need to know, like, how long ago did a pawn move happen, when was the last capture. So I think, yeah, I'm going to say Thinking about this some more. Think board should be responsible for knowing what piece, if any, was taken. Then undo move just becomes undo previous move with no arguments. I think that's cleaner. Yeah. Also, because something that was looking a little challenging here is because we have just one board state for the whole engine, and we're passing around, we can only sort of do one alpha beta call at a time. But if we sort of made copies of the boards and we passed in the copies, well, that's a little easier to do. They're sort of like we're not messing with the state of the board. Because sort of the way it is right now, like the board changes to so many different states. But I think the board for the engine should just be like the board of the game. And if we want to change, we want to generate different boards, that should probably be their own variables. Yeah. Also, I think instead of changing self.board all the time, we should make board an argument into, I guess, best move? No, it would be into alpha beta. Or into alpha beta. Changing arguments of the class member. Which actually, if I think about that as well, I think that's the only member. Yeah, we could then. Yeah. Although, I guess it would probably change because the evaluation function should be. Where is that? That's up here. Yeah. Because evaluate should be part of the engine, not part of the board. So I think that makes it clearer. Yeah. Okay. Okay. So we would go through all the moves. We change this. We've got make move. We recurse one down in that. With yes, those variables still carry over. So I think we want to change that false to something else, but I've commented on that in a previous PR, so we'll hope I did that. And then we undo the move, and yeah, if the evaluation is better, we save it. We get our max alpha. Yeah, so this is really the alpha beta difference. Yeah, this code there and that code there. The rest is basically the same. Which that looks right to me, yeah, so far. Beta is worse than the alpha we have found. We stop. Yeah, I think that's. Yeah, I think that's right for the two of them. Not 100% sure. But yeah, because mini value. Yeah, because we start. Wait, alpha first? Yeah, so we start alpha, so we start alpha at negative infinity, beta at positive infinity, and whenever alpha then gets better than beta, we know we can sort of trim that branch and stop looking. Okay, and then if that happens, we return the best move. Okay. Evaluation? Max evaluation, okay. And yeah, so here's the part. So now we've got that. I guess I should have noticed this for the min-max approach as well, but like the two sides are very similar. Like the difference. So they both have, so they both have the same, like this condition here. Well, sorry. This is the same break. They're changing a different one of them, but it's very similar. It's go through all the legal moves, make the move, first by one, undo the move, which actually if we're doing a... Oh yeah, if we're doing throwaway boards, we don't have to undo the move, we just toss the board away. Okay. But yeah, it's very similar. Makes me wonder, I guess. Is there a way we can make these two parts, the statements, a single function? Right, because I had run into an issue when I was trying to fix the stuff where it had something a little wrong, the capture piece line, and I changed it in one spot and then I crashed in the other one because it's doing the same code. So, I mean, or I guess maybe even you just... No, because you need that, yeah. Feels like there should be a way that we can pull out more of the common code there. Okay, and then, okay, best move just works by, it does the alpha beta. Yeah. Infinity, negative infinity alpha, positive infinity beta, and we are maximizing. Okay. And then undo move, yeah. As mentioned, we're not testing, alright, testing that the piece returns after a undo. If there was a capture. Okay. Okay, and then, this testing is, I guess I said originally with the min-maxing, I'd get rid of this because it's an implementation detail. So I think we're better off testing that best move returns the moves that are correct. So, instead of testing alpha beta directly, could we have a test board with only two moves, one of which leads to checkmate next turn, and ensure it because I think that's a better way of testing this. Okay. And I think that's everything for this one. I mean, most of the things that actually I'm noticing here are from previous PRs that I hadn't quite noticed when I was looking at them and sort of see now. And I think that's also a good argument for why you want to review multiple times, but more than multiple times of, you leave some comments, hopefully covering the whole thing, but then when you can come back, you can get a fresh set of eyes and sort of be like, okay, like, now that those things have been addressed, am I seeing anything's there? Ideally, though, you can hopefully make all the comments all at once, reduce the back and forth, but it is nice sometimes to sort of see things and be like, okay, I didn't realize this thing here because of this, which I guess maybe is also a nice little argument for why smaller PRs can be better. Okay. Oh, I'm still doing about a comment per 10 lines. But yeah, that wraps it up for this one here for the shift from MiniMax. And that's it. I've now reviewed all 3 initial PRs from ChatGPT, so I think it's time for me to share my overall thoughts. So I had asked ChatGPT to give me a basic chess engine that can communicate through UIC, and it gave me that code. But oh, there were a lot of issues with that code, and I probably didn't find everything. And these aren't super weird edge cases either that will only maybe hit. They're fundamental issues that need to be addressed. The engine doesn't seem to have any concept of check, so it'll try and make moves that are illegal because they expose the king to capture. And given that chess is all about capturing the king, I'm a bit surprised that this was an issue that made it in. There's not even a comment from ChatGPT noticing that problem. The end result is that this engine can't play legal chess yet, and it's not just one thing that needs to be fixed. It's a bunch of things. Since recording these reviews, I've gone in and merged the code after making some changes. I generally fixed the smaller changes before merging and marked anything else that felt biggish with a to-do for either ChatGPT or myself. Now, what metric did I use when deciding if a change was biggish? I didn't really have one, I just kind of went by feel. Basically, if I felt I could safely make the change in a few minutes, I did it. But as I've already mentioned, with the number of issues that I was seeing, the relatively light test coverage, and a test suite that wasn't even all passing, I didn't feel much confidence to make changes. So at this point, if I was to go back to this repo, I think it's clear that I'd focus on getting the current tests passing and then adding the basic functionality and tests to make sure we have that basic functionality. I think I'd probably set a goal of just getting the engine to a state where it could play another engine over UCI and not make any illegal moves. And I think that could take a while. In retrospect, I probably shouldn't have changed these 3 reviews together, but instead I should have focused on getting one component fully working at a time. I should have ensured that we had an engine that could find all the legal moves before adding UCI support. That would have given each change a stable base to build off of, instead of each unstable change landing on an unstable base, leading to an unstable project. Please let me know if you'd like more videos like this, either where I review code that ChatGPT writes, or maybe just working on this repo myself and trying to get a working chess engine from the state that ChatGPT has left it. I still think it could be fun and interesting to do that and get this code working. If you enjoyed this video, please consider hitting the like button below and subscribing. If you have any comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day!